Column-wise addition, that gives the voltage relation. If we are adding these columns, in that case, it will give the voltage relation. This here, this voltage is Vx voltage for first cassette. This voltage is a Vy for second cassette, and this is the voltage is a Vz for third cassette. What is the cassette? Indirectly, this fundamental cassette is very same as a node. It is very same as a node. Means here Vx, Vy and Vz are the node voltages. This method is very similar to the first method which we have discussed, which is nothing but reduced incidence matrix. It is similar to that. This is Vx, Vy, Vz. These are the three nodes. Node X, node Y and node Z. Means indirectly cassette number 1, cassette number 2, cassette number 3. And V1, this V1, this V2, this V3, this V4, V5 and V6. These are, this is V5, finally it is V6. These are the branch voltages. And here we are finding the relation between the branch voltages and branch currents. Now look at here, I will discuss this. Column-wise addition gives the relation between the three branch voltages. Three branch voltages, Vx, Vy, Vz, and the branch voltages, which is nothing but V1, V2, V3, V4, and V6. To be exact here, column-wise addition gives the relation between cassette voltages. Here it should be the cassette voltages. I will correct it. Cassette voltages. Cassette voltages, which are Vx, Vy, Vz in this case, and branch voltages. That is the case. Cassette voltages, Vx, Vy, Vz, and the branch voltages, which is V1, V2, V3, and V4. Now look at, if we are adding this column-wise addition. Column-wise addition. In this case, what we have? In this case, we have, this is V1. What is this V1? V1 is the voltage of the first branch. This first branch voltage V1 is nothing but this is minus, which is Vx, and this is minus, which is Vz. Now look at this V1 is equal to minus Vx minus Vz. This V1 is equal to minus Vx minus Vz. How is the V2? This voltage V2. This V2 is nothing but plus Vz. Look at this V2 is same as Vz because this is Vz. How is the V3? V3 is same as Vy. V3 is same as Vy. How is the V4? This voltage V4. This V4 is very same as Vy plus Vz. This is Vy plus Vz. And V5 is same as Vx. This is V5 for the voltage for the branch number 5. V5 is very same as Vx because only the X is present here. This is cassette number 1. This is cassette number 2. Cassette number 3. Its potential is Vx, Vy, Vz, and finally for the branch number 6, which is the branch 6 voltage, that is V6. This V6 is nothing but minus Vx, minus Vy, and minus Vz. This minus Vx, minus Vy, and minus Vz. This is that matrix, or this is those equations. Now again, these equations we will organize, or we will arrange these equations in the matrix form. Look at how will be the matrix. This V1 is equal to Vx minus Vz. This V2 is this value. I have copied these equations from the previous slide. If we are preparing this matrix equations, how many equations we have? 6. Means unknowns we have V1, V2, V3, V4, V5, V1, V2, V3, V4, and V5 and V6. This is column matrix. For V1, how will be the entry? V1 is nothing but multiplication of this first row, first column. Is it right? How is that? Vx its entry is minus 1, Vy its entry is 0, and this Vz its entry is again minus 1. This is minus, that's why it is minus 1. And if we are multiplying this by this, we will get this equation. It's from these equations we are preparing the matrix. How is the entry for V2? Vx is 0, Vy is 0, Vz is 1. Vx is 0, Vy is 0, Vz is 1. Means if we are multiplying this row and this column, in that case we will get this equation, and so on. We'll prepare this matrix. Now look at, if we are comparing this matrix with the previous matrix, which is this, what is the similarity? Now look at this row. What is this row? minus 1 triple 0 1 minus 1 minus 1 triple 0 1 minus 1. Look at here, minus 1 triple 0 1 and minus 1 means the row in the fundamental cut set matrix which has become here column. Again, the second row 00 11 0 minus 1 00 11 0 minus 1. This is second column, and this third row is the third column, and this matrix is known as the transpose of the fundamental matrix, and this is Vx Vy Vz. Indirectly, if I am writing these equations in the compact form, this Vb is equal to, Vb is nothing but branch voltages, is equal to this matrix which is the transpose of the fundamental cut set matrix, and this Vx Vy Vz are nothing but the tie set voltages, cut set voltages, that's the Vt. It should not be the T, it should be the Vc, that is, yes, in short, this Vb is equal to Qf transpose into Vc, that value. If I am going further, this Vb is equal to Qf transpose into Vc. This is Vc, cassette. This is Vg. Column matrix showing the tree branch voltages. It is not the tree branch again. This I will correct it later on. Actually, it is cut set voltages. These are the cut set voltages. This Vb is equal to column matrix showing the branch voltages. Qf transpose is the transpose of the fundamental matrix, and this Vc is nothing but column matrix showing the cut set voltages. Cut set voltages. It is cut set voltages. Yes. This cut set voltages. Okay, fine. Then I will come to the next point. This is about the column wise addition. The next is the row wise addition. Next is the row wise addition. If we are finding the row wise addition, it is same as the KCL, that is Kirchhoff's current law. In general, in case of the nodal analysis, when we are interested in the calculation of the node potentials, node voltages, because this Vt is nothing but, or Vc is nothing but node voltages, cut set voltages to be exact. Now, in this case, row wise addition will give the KCL. How is the KCL? If I am adding this is minus I1, because I1, I2, I3, I4, these are the branch voltages. Branch currents. Row wise addition gives the relation between the branch currents I1, I2, I3, I4, I5 and I6, which is KCL. This here it is minus I1, this is 0 I2, 0 I3, 0 I4, and this is plus I5 and minus I6, which is equal to 0, is application of the KCL at that particular node. This cut set is nothing but indirectly it is a node. Is it right? How is the addition for the second row? This is 1, 1, minus 1. Means here it is, this is I1, I2, I3, means plus I3, plus I4, and minus I6. Plus I3, plus I4, minus I6 is equal to 0. In this particular case, if I am coming to the last row, what is the last row? Minus 1 means it is minus I1, this is plus I2, this is 0, this is I4 plus I4, this is I5 0, minus I6 which is equal to 0. This is the way of the preparation of the row wise addition. Now in this case, if I proceed further, now I will copy these equations and I will try to organize this equation in the matrix form. If I am arranging these equations in the matrix form, how is the first equation? This row and this column is equal to 0, because everywhere we have 0. This is 0, this is 0, and so on. Is it right? This is minus 1, I2 is 0, I3 is 0, I4 is 0, I5 is this value plus 1, and I6 is the minus 1. This row and this column gives this equation. Is it right? This indirectly, in this particular case, from these equations, we are preparing this matrix. And if I am arranging this equation in the compact form, this is QF into IB, which is equal to 0. This is QF into IB, which is equal to 0, because this matrix is very same as the fundamental cut set matrix. Minus 1 triple 0 1 minus 1. I will go back. Minus 1 triple 0 1, and this minus 1 is that matrix. This is QF. This is IB, means QF into IB, which is equal to 0. This is the row wise addition.